Hello, welcome to this video on using complex numbers and Demoivre's theorem to solve problems involving the sum of a series. We're looking at a problem from Core Pure Mathematics Book 2. It's exercise 1E, question 6. And what we have here is we are given two series, C and S, defined as C1 plus n choose 1 cos theta plus n choose 2 cos 2 theta, etc. And then S is n choose 1 sine theta plus n choose 2 sine 2 theta plus etc. etc. Chosen this one because it's a particularly interesting one and we'll hopefully see why. Now let's first have a bit of a play with this. So I can think about C plus IS first of all, as you can see. Well, if I did that, I would get 1 plus n choose 1 cos theta plus I sine theta plus n choose 2, lots of cos 2 theta plus I sine 2 theta plus, and we can see the pattern hopefully, what I'm trying to show there. So we're just combining these two series first of all. That's our first job. I then want to put that into exponential form. So 1 plus n choose 1, and this becomes cos theta plus I sine theta. I can rewrite as e to the I theta plus n choose 2 e to the I 2 theta plus n choose 3 e to the I 3 theta, etc. And you can see the pattern there. Now, hopefully, what you might see there, or what you might imagine with this, would be a binomial expansion. The clue is hopefully in the n choose 1, n choose 2, n choose 3, and we're going all the way up to n. And that's going to help us prove this result here of what C is eventually. We've got a few steps to go though first. So the aim is to show that when C can be written as 2 cos theta over 2, or to the power n times cos n theta over 2. So if we have this, and we imagine this as a binomial expansion, what's it a binomial expansion of? Well, it would be a binomial expansion of 1 plus e to the I theta n. Now, recognizing that is obviously difficult, can be a difficult step, but once you realize that and you can see what would happen, it now makes it a lot easier. Well, that's really helped us out because suddenly we've written C plus IS in that nice form. Now we're going to take a nice little step, a step that we've seen before. I'm going to take out a factor of e to the I theta over 2, and I'm going to multiply that by, in the bracket, if we see this, here we go. That would be e to the I theta, negative I theta over 2, plus e to the I theta over 2. Hopefully that's a trick you're familiar with. It's exactly the same thing. That times that is 1, and that times that is e to the I theta. What it does is it does help us rewrite this. So what I would have here is e to the I theta over 2, and in this bracket I can put this into cos and sine form. Well, this would be cosine of negative theta over 2 plus I sine of negative theta over 2. I'm going to try and fit this in. Plus cos of theta over 2 plus sine of theta over 2. Well, that's times I. Right, what happens here is quite fun. It also begins to simplify quite nicely. Now, cos of negative theta over 2 is just the same as cos of theta over 2. Think about your symmetry with cos. Cos theta is the same as cos negative theta. Hopefully, an understanding the function will tell you that. Then I sine negative theta over 2 is actually negative I sine of positive theta over 2. So I'm just making the angles positive there. Hopefully that is clear. Well, what do we do next? Well, we just leave cos the same. So plus cos of theta over 2 plus I sine of theta over 2, all to the power n. Well, that turns out very nice indeed, doesn't it? Because the I signs cancel out because they're negative and they're positive. And so you've got e to the I theta, so it should be over 2, I believe. And then we've got 2 cos of theta over 2, all to the power n. Okay, let's continue. So we have this situation here. So I'm going to just bring the power of n down and write this as e to the I n theta over 2. And I'm going to leave that as 2 cos theta over 2, all to the power n. And we've got, as you can see, if we just look back at the question, we've got part of what we needed here. We just need to sort out this cos n theta over 2. And that will come in a second. So let's just deal with this bit here. I've got this, and now I can rewrite that. Let's put it into cos sine form. That would be cos of theta over 2 plus I sine of, well, n theta over 2, sorry, I apologise, n theta over 2. And there we have an expression for C plus IS. Now, I just want C. The question wants me to get an expression for C. There you go. It tells me what I need to get. So what I do is I just take the real part of this. So C is the real part. The real part is C. So the real part would be that multiplied by that. If I wanted the imaginary part, it would be this multiplied by this. So the real part is cos n theta over 2 multiplied by 2 lots of cos theta over 2, all to the power n. Now, hopefully that's what we wanted. And there we go. I have written it the other way around. I've written that before, but it's exactly what we want. There you go. Now, it does ask for part B. Part B would be S over C. Well, what is S over C? So B, S over C would be the real part over the imaginary part. Well, let's have a look. Let's write this down. I would get cos n theta over 2 to cos theta over 2 all to the n over the imaginary part, which is my I sine n theta over 2. Well, I've done that the wrong way around. That's C over S. I apologize. We'll flip that round in a minute. 2 cos theta over 2 to the n. Well, let's have a look. If I write that the other way around, what is S over C? I've obviously written C over S. I want S over C. Well, what does that equal? That is going to be sine. This is the imaginary part. So actually, I don't need the I because that's implied as it's the imaginary part. N theta over 2 over cos n theta over 2. We've also multiplying both top and bottom by 2 cos theta over 2 all to the n. If we think back, so they cancel out. So I've got my imaginary part over the real part, which is what the S over C is. And that gives me, as required, tan of n theta over 2. Sine over cos is tan. And the second part really is very quick. So what I'm doing is I'm taking from that the imaginary part, those two multiplied together, over the real part, those two multiplied together. So we've done quite a bit there. Just have a quick recap. So there's the question. The first bit's the crucial bit, really. That's where all the work is. We've got C and S defined. We're going to show that this is C. I combine them to form a series of C plus IS. Just write the first part. We get the idea that that is a binomial expansion. The clue is in the choose function. So it's a binomial expansion. I write it in exponential form. We manipulate it as appropriate, working between the exponential form and the sine and cosine form until eventually we get what we need. Well, I hope that made some sense. Thank you very much.